Alright, so first topic is immutable objects or immutable collections. I already did create a project here on my ADE, but I'm basically going to put all code here, and I'm going to upload on GitHub and then put a link in the video description. But basically, they're going to be all under one repository, so you can actually see all tutorials and all the code that I've written. And I'm going to code along with you guys, so you see exactly what I'm doing. I'm not going to show you guys an already written code and then just go over it. We're going to write the code together, and yeah, feel free to ask any questions in the comments or yeah. So let's go ahead and get started. Alright, so what is an immutable object to begin with, right? So you need to know exactly what it is to understand why Java from the get-go does not support immutable collections, but why we should have immutable collections in our code, and why it's important. So according to Wikipedia, in object-oriented and functional programming, an immutable object is an object whose state cannot be modified after it's created. So what does this mean, right? It means you create an object, and then the state of the object cannot be changed in code after it's initialized. So you cannot have any setters, set anything in the object, you cannot change the object itself in any other way, inject something into it, or remove something out of it, nothing. Especially when it comes to collections, because that's what collections are. That's what they're known for. You create a set, you create a list, you add something, you remove something. State of the object and state of the collection changes constantly. But what if you want to create an object? What if you want to create a collection that cannot be changed, which is actually a pretty normal use case, which is a pretty common use case. So what would be a use case for an immutable collection? Well, we'll give you an example. Let's say you know there are 3 images that you want your program to download. So you create a list with all those, with 3 URLs. And your first instinct will be to do something like this in the code, right? Actually, let's make it a list. Do this in a list. So, is this really immutable? No. Just because you declare it as static and final doesn't mean it's immutable. All you do when you declare a variable static and final is simply that. It's static and final. Meaning you can access it statically, and then there's always one instance of it. And it's final, meaning not the state, but the instance of it cannot be changed. Meaning this is invalid, and as you can see, my ID won't allow it. Why? Because it has to be initialized here, and it was initialized here first, so you won't be able to initialize it anywhere else. Because why? Because it's final. But does this mean you cannot change the contents of it? Sadly, no. You can do alright. So now I added another URL to it. So basically, this URL list is not immutable. It's just static, final, but it's not immutable. Contents of it can be changed. And if you're actually creating an API where a certain piece of code like this is exposed to another developer that's using your code, this is actually extremely dangerous, because they can't alter your code, and your code may or may not behave entirely differently. Let's say you create a library, right? You expose these, you have these URLs embedded into your library, and then developer has access to it, and then he can add or remove URLs from it, and then the code will behave completely differently. So you want this list to be immutable, otherwise it's completely useless to you. So how do you achieve that? How do you make a list immutable? Clearly, making a static and final isn't the way to go. So how do we do it? And then is there another simple way to achieve this kind of behavior? And that's what we're going to cover today. All right, so this is the code we have so far, and we're just going to get rid of it. we'll keep it here for now. So, all right, what is a list? We have an array list that is extending an abstract list, which implements a list. What is an abstract list? It's an abstract collection. What is that? It's a collection. So we want to create an immutable collection. But in this particular case, it's a list that we're after. And it could be an array list. And then if you go back here, you see that it has certain behavior, and then the underlying data structure for it is an object array. So we're just going to keep that. We're actually going to keep an array list as our underlying object. And then we're going to make it immutable. And how do we do that? Well, I'll show you. So let's create a package here. Let's call it immutable objects. Then under that package, we're going to create a Java class immutable list. All right, so we have a class. So first of all, it has to be a list, because just because it's immutable doesn't mean we don't want it to be used as a list. It still needs to support all functions that the list supports. So what we're going to do is, if you go back here to the array list, let's see what it extends exec. So it extends an abstract list, and then it had implement list, random access, clonable, serializable. So we're just going to ignore these two for now, because they're not a whole lot important. And then, well, they're actually quite important, but they're just outside the scope of this tutorial. So we're just going to use these two right here. Okay, so I'm just copy that. Come back. Actually, you know what? We're not going to use abstract list. We're just going to use list. And you'll see why. So going back to our immutable list object. If you don't know a whole lot about generics, I don't even consider generics to be an advanced topic. You need to know generics. So I'm not going to cover it in this tutorial. Alright, so what do we have? We now have a list object that currently doesn't do anything, right? But we needed to do something. We needed to be a list, but also, more importantly, an immutable list. Looking at the array list, it became apparent that the underlying data structure is an array, but since we're not actually creating it from scratch, we're not going to do all the things that they do here. We're just going to actually use an array list as our own underlying data structure. So I'm going to go ahead and do this. Final list equals. I'm going to call it data. Wait, yeah. So let's create our constructor. And our constructor is going to accept an array object. Oh, data. And then we're going to create our array list and populate it with the data that's given to us. How do we do that? Arrays as list. Okay. Perfect. Actually, I'm just going to do this. Alright, so what's going on here? We created that immutable. We created a list object that accepts an array inside its constructor, and then using that array, create an array list, and then just basically, well, right now it's a list, but it's an array list, so it holds an instance to an array list as the underlying data structure. And so far, it's technically speaking not different from a regular list at all, but it's going to change. So size size data empty. So basically everything else, all getters, well, yeah, all methods that query this current state won't be altered. We're going to keep them as is. So add and remove, that's where all the magic is going to happen. Well, I'll show you. So let's just do the rest. Again, these are mutators, so we're going to get there. Clear mutator, get, not a mutator. Set mutator, nope, nope, nope. Remove, nope. Index of, we'll do it. So, cool. This is all like redundant stuff that's painful to do, but I'm just doing it to deal with you guys basically. Alright. So all the query methods are basically querying our underlying data structure, which is our data. But we also have these methods, for instance, add, remove, add all, remove all, clear. So there's a couple things you can do. Right now they do nothing. Technically speaking, this class as is an immutable object. It's immutable. So once you start it, the only place it's being modified, or it can be modified, well, it's not a modification at that point. You just give it a data inside the constructor, and then that's it. You cannot change the data after that. So you can either leave all this as is, or, like I said, if you're creating an API for immutable list, like this is data that's being exposed, and then you want users to know that they're using it. Because you do nothing here, like I can still call the add method, and I wouldn't know I'm doing something wrong. So I wouldn't know that because I wouldn't know that I'm not supposed to do that. But you need to let me know that that's something I should not be doing. So the safe bet here would be to actually throwing an exception to let the user of this API know that they're doing something they're not supposed to do. So I'm going to create an exception here. Let's do it here. Alright, create that now here. Okay. Alright, so let's quickly go over what we did so far and what we wanted to achieve. So we wanted to create a list that's immutable, meaning the contents of the list cannot be changed, because we realized that when we create a private static final list, it's not necessarily immutable. So we wanted to actually make it immutable. Oh my god, I hope you guys see. So it's not actually immutable that way. So we wanted to create a list that's not modifiable. Contents of it cannot be modified. So what we did was we also realized that array list basically relies on an interface called list. So we basically, using that list, wanted to using that list, we want to create our own data structure that basically behaves like a list, but it's just that it's immutable. So we create this immutable list class that basically uses an array list as an underlying data structure. It accepts an array of data of any kind, and then it stores that in a list, and then all getter methods all getter methods basically pass the method onto our underlying data structure, meaning when you check the size of our immutable list, we check the size of our underlying data structure, because they don't actually change the contents of our data structure. But all of our mutator methods throw an exception. They throw an illegal access exception, which is basically a runtime exception, and the message is object immutable, meaning whoever uses this immutable list and they attempt at changing the content of it, they'll get this exception, meaning they're doing something they're not supposed to do. So how would this list be used? Again, let's go back to our main example here. So I wanted to add one last thing here. I really don't want users to have access to my constructor, so I made it private. Instead, I'm going to create a static method here. And this will allow users to create an immutable list of any data piece they would like to use. And return list data. Perfect. So this is our code. Yeah, I'm sorry that I forgot to zoom in earlier, so if you weren't able to read my code here, I'll put it on my repository so you'll be able to see it anyway. So let's go back to my main class, zoom in a little bit. Let's create this. Say okay. So I forgot to add the toString method here. I'm going to basically just use So let's go back here. List. Alright. Let's get rid of this. Let's run main, see what happens. So it behaves just fine. So let's check. Let's see if it's actually immutable. Meaning, can we add something to it? Let's run it. Nope. Immutable. Let's try to remove something. Let's remove one. Nope. Cannot change the state of the object. Perfect. This is exactly the type of behavior we wanted. So go back here. I want to add one last thing here. I want to make this class final. So it cannot be extended, because if you extend it, then you can still technically do stuff to it that you may or may not be supposed to do. Because so you can extend from it and then use a separate underlying object, and then since you still have to technically expose some of the methods, then and you're using a separate underlying data structure, then you can technically alter the state. So you want to make it final to prevent users from changing the state, period. So right now, this class is complete. You can do the exact same thing that we did here for set, for all sets, for hash maps, maps, basically any other data structure that Java already supports. But I wanted to end by saying that you don't technically need to do this, because there already is a library that does this for you, which is Guava by Google. So if you just use Guava libraries provided by Google, then they already have immutable lists, immutable sets, immutable maps, so you don't actually need to write this code yourself. They've already written all of that for you, and it's a lot more compressed than what I've just written in a couple minutes here. So I just want to do this with you guys so you guys know exactly why we're doing this and how Google achieves immutability on these objects. They're doing something similar and almost identical, actually. So yeah, instead of using this, use Guava libraries. I'm actually going to put a link to Guava in the video description also. Yeah, hope you guys liked it. And then the next video will be about multi-object builder pattern. And I'll see you guys there.